Good morning. We're back working on the 32 Ford 5-window highboy project and thought we would point out a couple of things about welding for starters. In the shop we have a weld stack, as I call it. I built this 20 years ago, use it on our race truck, and we have a MIG, we have a AC/DC TIG unit, we have a MIG, and we have a plasma. And doesn't have to be in every shop. Haven't used a stick welder in probably 30 years, but a TIG and a MIG come in very handy, and especially a MIG welder. And with that being said, one thing I wanted to point out that a lot of people don't realize, we have a situation here where we're welding all over this chassis. The motor's a dummy, so it's not that important. But I'm getting ready to do some layup and welding on the rear end. Now, a lot of people will just routinely put the ground on some spot on the chassis and have at it. Well, what you don't realize is the ground has to find itself all through the intricacies of the pieces and the parts. And perhaps if you had a motor in this and you were going to weld at the front and put this ground on the back, that ground may have to find its way through the transmission, the rear end, or the engine before it gets to your weld point. So in this case, what we're going to be doing here shortly is welding the brackets on for the trailing rods for our 4-bar triangulated suspension. And what I've done is put this clamp on the rear axle itself, and I'm putting the ground on the clamp because we're going to be welding only about 4 inches away from it. Therefore, the ground doesn't have to find its way through the bearing or the rear end gears or something else where it can arc. And an arc in a gearbox or an arc in an engine can be devastating. It can wipe a bearing out in the not only the rear end but also in the engine. So just wanted to point that out. It's a small little thing, but it can be very catastrophic and costly if that arcs in the wrong place. Could be a front wheel bearing or a rear wheel bearing that it could arc, and it might damage that bearing, burn the bearing up, lock a wheel, and could possibly cause an accident. So that's a little tidbit for today before we start doing our final welding on some of these brackets. What we're doing here is making our rear trailing arms for attaching the rear end and our 4-bar triangulated system. This is going to be the bottom, one on each side, and what I'm doing is I'm taking a front wishbone and cutting it and taking the wishbone attachment to the I-beam axle off. And what I'll do is once we've got them cut, I'll put an 1.5 inch hole and a bushing and a sleeve inside of this to give it some compliance when it's mounted to the axle. What we've done is we've marked this just behind the weld because this actually has a protrusion that goes in the tube itself. So we're going to cut this, and then hopefully it'll be just in the right place that what's left will fall out. So we're going to cut it. This nice tool here, I sold my vertical saw and went to this, and this is just a Dewalt handheld power saw that you can put into almost any position and cut anything you want, tubing, bar stock, or otherwise. So we're going to cut this right now. It'll take a minute or so. Now cutting it just shy of falling off, breaking off the, and you can save these. These actually can be reused and fabricated into a split wishbone that's like a hairpin, and weld a tube on the top and come back. But anyway, they'll go in my temporary junk bin. That said, we're going to clean this up, clean a little weld that didn't get completely cut, and this should fall right out. 3/4, and we're going to go out here 1.5. So what we're going to do here is put a temporary 1/2-inch hole through here, so we can put a 1/2-inch bolt and just let it rest in our bracket and be approximate to then determine where we want to be with our bracket at the front. So we're just going to drill a couple pilot holes, one in each, and then we're going to come back with a 1/2-inch finish hole. Alrighty. Now, we've got those 2 reference holes, and they will become the temporary bolts that go through our bracket on the axle to determine where we actually weld the front axle, the front bracket for the trailing arms to the frame. And we're going to move over. What we're getting ready to do now, we have cut a set of wishbones and put a reference hole in the back end of each one. That reference hole is going to loosely match up with these axle brackets that will be welded to the axle and support the coil over, which will come from here to here, and of course ultimately support the car. We've cleaned them up a little bit with the bead blaster to make for a nice clean weld where we're going to tack it on. And of course we're going to tack this on first just to be sure that we are in close proximity to our carpenter squares and to the table. So what we're going to do now is I'm going to hand hold these and position them and tack them, and then we're going to loosely fit this piece with a 1/2-inch bolt. Even though this is a 5/8 hole, we're going to put a 1/2-inch bolt through it and get our position for where this front mount has to weld to the side of the frame. And this will be the front mount. It'll actually weld in position once we determine the position right here, and one on the other side in order to tie the rear axle to the frame with the lower control arms. So that's what we're going to do next. Tack that puppy on, loosely fit, well, both of them side to side, loosely fit all this and determine where we need to put the front bracket and the adjusters. Keep in mind all these have adjusters on them at the ends of each of the control arms, which gives you flexibility. You can be off a little bit and adjust that out. If you're too tight and don't have any threads left, then that isn't going to work and you're going to have to remake something. We're now going to tack the brackets on for the lower control arms. I'll point out one little thing that I did. Is at Cabela's, I bought this little light, and it's kind of, you know, Rube Goldberg on here with some red duct tape, but this is a high intensity light that also points at where I'm going to start the weld and tack. And it's very helpful because sometimes you're in a close quarter and you don't have the ability to see the work that you're getting ready to work on. This comes in immensely. So I'm going to move forward and tack those on. Okay, we're back in the last Farrar garage today working on the 32 5-window highboy that we're constructing, basically with the concept of trying to do this predominantly with bolt-on parts. Obviously there are some things that need massaging, and somewhat that is driven by personal values, such as in our case here, I like the control arms in the rear to be similar to the split wishbones in the front. So we took a reproduction split wishbone and cut the end off of it in order to allow it to mate up to our down bracket off the rear axle. Now these are not to be thrown away because these can be turned into hairpins, or they can be reconstructed in a different manner to be used also as a wishbone in the front. That said, what drives that is that the wishbones are tapered, and it happens to be a personal aesthetic value to me to have the same similarity front and rear, front wishbone to rear trailing arm, lower trailing arm, that allows for the taper to be seen from the side view of the chassis when it's sitting statically. And in our case here, our trailing arm ends up being the lower control arms to what will end up being our triangulated 4-bar. We're going to have a connector here, an arm, and an arm over there, and once those are established and they're put into place, that triangulation prevents the rear end from moving back and forth in the chassis, just like a panhard rod does, or a Watts link. And it allows for very acute articulation of the axle. It's a very smooth ride. It's not choppy. A lot of times a panhard rod used from the center to the side is so short that the ride becomes choppy because the body moves back and forth. So what we've done is also, in establishing closing in on, I should say, our final visual ride height, is that we've lowered the chassis in the back by 1.5 inches in order to get our side profile view visually to where the lower control arms are parallel with each other. Now, by doing that, that necessitates us having to, and as I'd spoken earlier about, we're going to have to refabricate this upper shock mount and frame tie in order to allow for vertical movement in the quick change rear end. So that's our next hurdle, and piece of the project is to reconfigure this to allow that quick change to move up and down in the given vertical distance and not run into the cross member. Okay, now what we're going to do is take a measurement for our upper triangulated arm, and that arm, following the tape measure, will come from a bracket that we have facsimiled over here with cardboard. We're going to take and mount a bracket there on this side, and that will end up taking a heim joint, a spherical rod end, and that spherical rod end will come over to this corner and connect and give the ability for the rear end to articulate left to right and up and down, but not move sideways. So these brackets here that we've modified are going to actually be welded in this corner, and then that arm will come, that control arm will come from the rear end to this bracket with a heim joint on each end. And what we're calculating right now is going to be something on the order of 23.5 inches. I don't have those yet, but that's a product that you can source from Short Track Racing, and they're control arm tubes, and they come in all kinds of diameters and lengths. And I'll source those from Speedway, and the length of what we need is about 24 inches long, and they're modifiable. You can cut them off because they have plenty of threads on the inside to make your final adjustment. We got a little fab work to do with this bracket, a little fab work to do on the rear end, which will tie into this. We won't actually weld on the rear end, we'll bolt that on once the duplicate of that is made for this side. And it'll be pretty much a bolt-on piece. It's another piece of welding, but minimal, that has to be done on the car.